Next, we will study about scheduling algorithms. So, these algorithms help us to understand that which process it has to be taken out from the ready queue and it has to be given to the CPU for execution. So, here we have six algorithms. The first one is first come first serve, that we call it as Fcfs. Next is SJF, that is shortest job first. Third one is priority scheduling. Fourth one is round robin, that is RR. Fifth one is multi-level queue scheduling, and the last one is multi-level feedback queue scheduling. Okay, so first we'll talk about Fcfs. Okay. So FCFS means first come first serve or first serve scheduling. Okay. So here, as the name suggests, first come first serve. That means the process which arrives first, it gets executed first. Or we can say that the process which requests the CPU first will get the CPU allocated first. So this is similar or your FIFO, right? This first come first serve is similar to the queue in your data structure. So that is also first in first out, right? So where the data element which is added to the queue first will be the first one to leave. So this is used in batch systems, and your first come first serve. It is easy for implementation, and it is easy to understand as well, right? So the real time example for this one is like your say suppose you are buying tickets for a movie. Then what do? You stand in a queue, right? You, if you go first, you will be getting the ticket first. So something similar like something similar like this one. Okay. So for every scheduling algorithm, the average waiting time is the crucial parameter to judge for its performance. Okay. Now the average waiting time is the average of the waiting times of all the processes in the queue. That is waiting for the scheduler to pick them for execution. If the average waiting time is lower, then the better the scheduling algorithm will be. Fine. So whenever the process enters the ready queue, what will happen is that particular process's PCB will be linked to the tail of the queue, and whenever the CPU is free, it would be allocated to the process that is at the head of the queue. So once the process starts running, then it would be removed from the ready queue. Okay, so we'll take the example, then you will understand here. Okay, so we'll consider this following set of processes, that is process P1, P2, and P3. They have arrived at the time 0 and they have the burst time as 24, 3 and 3. Okay, they have come in the order P1, P2 and P3. So here burst time is nothing but the time required for the process to get executed. Okay, so say P1 has 24, burst time as 24. That means your process P1, it requires 24 milliseconds to completes its execution. Okay, P2 and P3, we have 3 and 3 milliseconds here. That means both process P2 and P3, they require 3 milliseconds to be executed. So whenever such kind of problem is given, okay, so again remember for your exams this would be a problem, right? So they would be they'll give the question and they'll tell that calculate average waiting time and waiting time for the processes, and they would give you the algorithm names. So we'll see that later. So first we'll understand how to calculate average waiting time in this first come first serve scheduling algorithm. Okay. So whenever you have got the set of processes and they are clearly mentioning that the processes they have arrived in the order P1, P2 and P3. That means P1 is the first process to arrive, then P2 and then P3. So according to our first come first serve algorithm, what it says? It says whichever process comes first, it has to be executed first, no matter what is the burst time of it. Okay, either it may be 2 milliseconds, 3 milliseconds, or 30 milliseconds, it doesn't matter. So, for that, first we have to draw the Gantt chart. Okay, this is the Gantt chart. Gantt chart is nothing but a visual representation. So this visual representation can understand that which process comes first, which comes next, how much time it would take for the execution. Okay, so this Fcfs is quite simple. So to draw this Gantt chart, first what we have to do is like, first thing, we had already understood that these processes P1, P2, P3, they have arrived in the order P1, P2 and P3 and at time 0. This is important. Okay, at time 0. Fine. So to draw the Gantt chart, just draw this rectangle kind of thing. Then, so this process P1 has entered first, right? So you have to execute that first. So from the 0th millisecond till 24 millisecond, you have to allocate that for process P1. That means, again remember the size here for the process P1, it matters. Why? Because it is 24 millisecond. So if you have equal sizes for P1, P2 and P3, that doesn't make sense, right? So 24 milliseconds would be allocated for the process P1. So you can see over here, right? The process P1, it arrived at 0th time and it requires 24 milliseconds to complete its execution. Okay, fine. P1 is done. Next, which process arrived? It is P2. And how much millisecond it needs? It needs 3 milliseconds. So process 1, it has completed its execution at 24 millisecond. After that, P2 arrived and it requires only 3 milliseconds. Now what you have to do is like, you have to add 3 to this 24. 24 plus 3 is 27. Okay, that is for P2. Fine. Next is P3. And how much is the burst time? It is 3 millisecond. Now you have to have P3 here at the last and you have to add 3 to this 27. That is 30. Now there is a way to check whether this whatever end time you have got right here 30, if it is right or wrong. So basic thing is like, add all this burst time. 24 plus 3 and 3, it is 30 milliseconds, right? So for process P1, P2, P3, it should be 30 milliseconds. So check whether it is proper. Here also you are getting 30, here also you are getting 30. That means your Gantt chart is right. This is one way to verify your Gantt chart whether it is right or wrong. Okay. Then, so now we have to check or we have to calculate the waiting time for each processes. Okay. So what is the waiting time of P1? How much millisecond it has waited to get the CPU? So as we all know, P1 is the first process to enter the system. So it has not waited, it has not waited. Whenever it entered, it got the CPU. That means your P1, it waited for 0 millisecond to get the CPU. Another trick over here is whatever comes to your left hand side. Okay, this one. In the Gantt chart, the left hand side of each processes, it determines the waiting time. Okay, your process P1, it has not waited for um, not waited for the CPU. Whenever it entered, it got the CPU. That means your process P1, it waited for 0 milliseconds. Then how much your process P2 has waited, right? So your P2 has waited for 24 milliseconds to get the CPU. Why? Because till 24 your P1 was executing and after that only your P2 got the CPU, right? So that's why your P2, it waited for 24 milliseconds to get the CPU. So the waiting time of P2 is 24 milliseconds. Next is P3. So how much time your P3 has waited to get the CPU? So your P3 has waited 27 milliseconds to get the CPU. So it is here. Waiting time of P3 is 27 milliseconds. Now you have to calculate the average waiting time, AWT. Okay. How do you calculate that? You have to add all this waiting time of the processes and you have to divide that with the total number of processes. That is, we have 0 milliseconds for P1, 24 milliseconds for P2 and 27 milliseconds for P3. This is the waiting time of these processes. Add up these all things, 0 plus 24 plus 27. The whole thing you have to divide it by total number of processes. That is, you have 3 processes, right? P1, P2, P3 divided by 3. So you'll get 17 milliseconds. Next we will see how to calculate the turnaround time. So I'll talk about this formulas later. Okay. So first I'll tell you how to calculate the turnaround time using only this Gantt chart. So in the previous slide also we have calculated the waiting time here just by looking at the Gantt chart, right? So we'll do the same thing for the turnaround time. So your turnaround time is nothing but how much your process has, how much time your process has taken from coming into the ready queue, doing its IO until its completion. So from the Gantt chart, how can we calculate the turnaround time is, so for the process P1, when it has completed, right, when it has left the system, so that we will be considering it as a turnaround time. So for process P1, it has completed at 24 milliseconds, right? Basically, if you are using Gantt chart, just look at the right hand side of your process. That would be your turnaround time. Okay. So for the process P1, 24 millisecond is the turnaround time. For process P2, it has taken 27 milliseconds, and for process P3, it has taken 30 milliseconds. So this is the turnaround time of the processes P1, P2 and P3. Now we will calculate the average turnaround time. The average turnaround time is the sum of all the processes divided by the total number of processes. So it is 24 plus 27 plus 30 divided by 3. That comes to 27 milliseconds. Now the way how we have calculated the waiting time and the turnaround time, it holds good only when in the question if they are saying the process they have arrived at the time 0. Okay. So remember, like the waiting time and the turnaround time, if you just look at the Gantt chart and then you are writing, then you have to make sure or read the question carefully. If in the question they are saying like the processes arrive in the order P1, P2, P3 and at the time 0 is very important. Whenever they are saying at a time 0, then only you can make use of the Gantt chart and directly you can have the waiting time and turnaround time. If suppose in the question say suppose they'll give for example they'll say like if the processes will arrive in the order P1 arrives at 4 milliseconds, P2 at 8 milliseconds, P3 at 6 milliseconds. If suppose something like this has been given, then you cannot make or you cannot directly see the Gantt chart and can calculate the waiting time and turnaround time. So whenever the arrival time for the processes whatever mentioned it is different, say suppose they'll give something like this arrival time, one more column would be there, and if you could see different 2 6 4 something, if you see different arrival time for the processes, then that time you have to make use of the formula. So the formula, whenever the arrival time is different, the formula is like, or basically you can take the same formula even if the arrival time is 0, you'll end up in the same readings. Okay. So to calculate the turnaround time, the formula is completion time of the process minus arrival time of the process. Then waiting time is equal to turnaround time of the process minus burst time. This one, okay, burst time of the process. So whenever you are making use of the formula, make sure first you calculate the turnaround time, then you calculate the waiting time. Why? Because for calculating of the waiting time, you need turnaround time. Fine. For this problem, we'll check using the formula, are we getting the same answer or not. Okay. The turnaround time for process P1, okay, we'll calculate for process P1. It says completion time of the P1 minus arrival time of the P1. What is the completion time of P1? It is 24 milliseconds. Then what is the arrival time of process P1? It is 0. We have assumed all the three processes will arrive at time 0, right? That's why 24 minus 0 is 24 milliseconds, which is same, right? Then we'll calculate the turnaround time for process P2. So what is the completion time of P2? It is 27 here. So 27 minus arrival time of the process P2 is again 0. 27 minus 0, you will end up in 27. So for the process P3, the completion time is 30 minus arrival time is 0. 30 minus 0, it is again 30. So the turnaround time for the, we have used the Gantt chart and we have used the formula also. In the both cases, we have got the same answer. Average turnaround time calculation would remain same. Fine. Then we will calculate the waiting time. Fine. So first we will calculate the waiting time for process P1. Okay. Now we have to check the turnaround time of P1 minus burst time of P1. What is the turnaround time of P1? It is 24. So 24 minus burst time of P1. What is the burst time of P1? It is 24. I'll write here waiting time. Okay, so P1, it is equal to turnaround time of P1 is 24, burst time of P1 is 24. So 24 minus 24, it is 0 milliseconds. Okay, next we will calculate waiting time of P2. What is the turnaround time of P2? It is 27 milliseconds. So 27 milliseconds minus burst time of P2, which is 3. So 27 minus 3 will get 24, right? Then for process P3, we'll calculate the waiting time. Okay, P3 is equal to turnaround time of P3, which is 30 milliseconds minus burst time of P3, which is 3. So 30 minus 3, it is 27 milliseconds. Fine. So we'll go back to the previous slide and we'll check whether we have got the same values. So P1 is 0, 24 for P2 and P3 is 27. It's 0, 24, 27. Let's check. It's correct, right? 0, 24 and 27. So if you apply the formula or just by seeing the Gantt chart also, you are getting the same result. Okay. Calculating of the average waiting time, it remains same. The only thing here you have to remember is whenever the arrival time is 0, then only you can directly see the Gantt chart and you can have or you can read the readings for waiting time and turnaround time. If suppose in the question they are giving the arrival time, different arrival times for different processes, that time make use of the formula, or if you are comfortable with the formula, use it. That is better. Okay. Hope you understood this one. Okay, so we'll take few more examples of Fcfs and we'll understand it better. One thing you have to understand here is your first come first serve is non-preemptive scheduling. That means, what is non-preemptive scheduling? The process will voluntarily give up the CPU, right? You are not forcefully taking, it voluntarily gives up the CPU. So you can see over here, right? P1, its execution, it terminated here, right? At 24 millisecond, its execution terminated. It gave up the CPU. Then came the P2 process. It took the CPU for execution. It terminated here. It left the it gave up the CPU, right? So FCFS is your non-preemptive scheduling. Okay. That's it for today. We'll conclude our session. Thank you.